Okay, so graphing on the iPad, on Google Sheet on the iPad, is a little bit different than doing it on a computer. And honestly, it's a lot easier on a computer, and you may have to do some of the finessing on an actual computer, but you can do a lot on the iPad. So if you enter your data exactly as shown here, with the columns exactly as shown, volumes and masses, and making sure that you don't have any units in there, okay? If you then highlight those two columns and go over to this upper right-hand corner and press the plus sign, you will get an option for adding a chart. So now it looks like this, and this is not how you want the chart to look. You want it to be a scatter plot. So once you click that, you go down here to scatter, it looks a lot more like how we want it. In terms of the legend, we can get rid of the legend. We don't need that. We don't have two sets of data on it. And now on the titles, you can change the titles. So right on the yellow handout, I tell you what I want the title to be. I believe it's your last name, first initial, and then something like that, right? So you put that in. Then your horizontal axis, right? The horizontal axis is the one that's going left to right, and that's your volume. And anytime that we have axes in science class, we need to label them with, words, but then also what units they're in. So you can see I changed that to volume in milliliters, and now the y-axis is mass, and that was measured in grams. Okay, once you have this, you can change the colors and, you can make it prettier or whatever, but that doesn't really matter. What we need to do now is do some more work on it. So if I press the check button, right, then it puts the graph right in the middle of my spreadsheet, and I can move it around to see it. And once I go to a computer, I can add the equation and the trend line and the R squared in. Those are the three things that you need in order to get full credit for this graph. So you do need to do those on a computer. But in order to do the percent error, what you need is the slope. And you can get the slope a different way than what it says on the yellow sheet. And how you are going to do that is by writing a formula. So taking any square, any cell, that's what these little boxes are called, and clicking on it. And when you click on it, you can see down bottom, it says enter text or formula, and you click on that and it will come up where you can write a formula. If you press the equals button, that tells the computer that you are going to write a formula. Basically, you're going to tell it to find something, right? And what I want it to find is slope. So I'm doing equals SLOPE. And then you start a parenthesis, and you can see that what happens is it says, okay, what data do you want to use for your y-axis? Remember, the y-axis is the rise, and that's the mass of the sample. So you can either, and we don't, only the numbers, right? So I'm highlighting these. So I can either type in B2 colon B7 comma, or I can do what I just did, which was highlight it. And now I just clicked over to the other side of the comma, and now it's saying, what are your X values? And so I will just highlight my X values there. And then if I think I have to close the parenthesis. Nope. Maybe I just go there and then press return, right? And when I pressed return, instead of, right, that was where I wrote that formula. But what it looks like now, right, if I click away from it, you can see there, and then there is the formula down bottom. So that's how I got the slope. The slope of that line is 6.909. And I know I look over my volumes were only two significant figures, right? I would have found this by dividing, so I can only have two significant figures. So I can report that my slope, which means my density, is 6.9, and I have to look at what would the units be, grams per milliliter. And the other piece of data that you can get this way is something called R squared. That's what this cell is giving us. So you can see the formula down the bottom, right, equals RSQ, and then the same way B2 colon B7 comma A2 colon A7. And it will give you this number. What this number means is how close your data comes to a straight line. And what that tells us is how close my data is to basically how close those data points are to each other, which is a way to look at precision. If my data was very precise and every single one of these numbers gave me the same density, it would be a completely straight line and all of those dots would be on it. But because they are not all on it, because they're a little bit off, then my data is not as precise as it could be. And that's why we get an R squared of 0.985. If I just go to, a blank here, right? So here would be my graph, here would be some data points, and here's the trend line. Do you see how many of them are not even on the line? This would be poor precision, and this would be, so low R squared, poor precision. But if the data points are all on the line, if I could have drawn that better, this would have a high R squared. So this might be like 0.999 or even 1.00. This might be like 0.95, right? And that would be high precision. So it's a way that we can quantify how precise our data is. And then accuracy, remember how close our data comes to the actual answer. That's what we use percent error to find.